Hi guys, in my previous video I talked about Kepler's first law, and in the next video I talked about Kepler's second law. Right now I'll be talking about Kepler's third law. Kepler's third law, and this law is regarding planetary motion. Okay, perfect. So from my second video, if you guys remember, the rate of change of the area swept by the planet was constant, 1 upon 2c. Now, let's say that I want the time that's taken by the planet to complete one whole revolution. So t is the time taken by the planet to complete one revolution. Okay, so I can replace the lowercase t with the capital uppercase. So dA over dt, uppercase, is equal to 1 upon 2c. What I will do here, I will just take t to the dt on the other side. I'll be left with dA is equal to 1 upon 2c dt, and I'll integrate both the sides as we do with first order differential equations. dA is equal to 1 upon 2c dt, and remember this integration does have limits because it's a complete cycle. We know where it's starting, we know where it's ending, so it will be A is equal to 1 upon 2 ct. Perfect. There you go. We have the formula for the area that is covered by a planet during an entire revolution. Okay. Now we know that we can make t the subject of the formula. T can be written as t is equal to 2a over c, and I will write this down here. T is equal to 2a over c. Okay, now sorry guys, I'll just reach out for my eraser, and now let me remove everything else. We know that the area of an ellipse is given by pi AB, where the length of the semi-major axis is 2a, semi-major axis is 2a, and the semi-minor axis is 2b. Semi-minor axis is 2b. Okay. Now what I'll do is I'll take the time formula, t formula. I'll replace the area, so 2 pi AB over c. There you go. Perfect. We have it as usual. We have it here. Now there is a relationship between the semi-minor axis, semi-major axis, and the eccentricity. So let's take a look at that relationship. So that particular relationship is given by b squared is equal to a, and for a reason I'm writing a. Okay, into 1 minus, and then we will have 1 minus e squared, where e is the eccentricity. Okay guys, now we have another formula from the conic section. We can write this down as ED is equal to a into 1 minus e squared. There you go. Okay, we have this formula, and then we can replace this formula. On the top formula, we'll have b squared is equal to AED. There you go. There's another formula that we have. I'll remove this part. Now, from my first video of Kepler's first law of planetary motion, if you guys remember that the conic section equation is given by, we used to have it here, c squared over gm, and then we used to have something such as let's put it this way, let's put it here, c1, and then we used to have c1 here, and then we used to have c squared again right there. Perfect. On the numerator, and then we used to have 1 plus c1 over gm cos theta. So if you remember, from here, from this equation of the motion of a planet, the ellipse of the planet is given by this equation. So from here we can write that actually this is the eccentricity, this is the E, and this is the D right there. This is the D. This is D, and this is E. This is the eccentricity. Perfect. So ED from this part will be given by, for a planet, is given by c squared over gm. So when we have that here, I can replace b squared is equal to a c squared over gm. We got it here, perfect. So now I'll have this equation and this equation, we'll play around with them, and then we'll see what the third law says. There's a reason I'm not mentioning the third law right now. I'll mention it later when we actually derived it. Okay, you have another equation right here where b squared is equal to ac squared over gm. Okay, now let's take t squared. T squared is given by 4 pi squared a squared b squared over c. Okay, perfect. Now let's replace b squared. T squared is equal to 4 pi squared, we'll have c here, 4 pi squared a squared into a c squared over, c squared over gm multiplied by c squared. So this c squared and this c squared gets cancelled, and then we are remaining with t squared is equal to 4 pi a cubed, 4 pi a cubed with over gm. Okay, so let me write this down here. So t squared is equal to 4 pi squared here, 4 pi squared a cubed over gm. We can simply write this down further as t squared is equal to 4 pi squared over gm into a cubed. So the third law of the Kepler's planetary motion is very clear. It says that the square of the time taken for the planet to complete one whole revolution is in fact proportional to the length of the to the axis, to the semi-major axis, okay, to the cube of the semi-major axis. So this time, the time taken for the planet to complete one revolution is proportional to the cube of the semi-major axis. So t squared is proportional to the length of the semi-major axis, the cube of the semi-major axis, and another derivation we can see that the time taken for the planet to complete one revolution around the sun does not at all depend on the mass of the planet. It only depends on the mass of the sun and the semi-major axis, that means the distance from the planet to the sun, and it also depends on the gravitational constant, which is obviously a constant. So two things determine the length of the planet. The length of the time taken for the planet to actually complete one revolution. So one of the first thing is mass of the sun. Mass of the sun or the star. Mass of the sun or star. And the second thing, that the time taken for the planet to complete one revolution is depending on the major length, major axis, or length of the planet from the star or the sun. From the star. So guys, this concludes our Kepler's third law of planetary motion. All the previous videos will have links to this third law, and obviously the third law will have the link in the description for the first and the second law. These show a very interesting application of vectors and calculus combined together with some previous extra knowledge of maths. So there we go. And if you have any questions, comments, if you want me to use vectors to prove something else, to see how vectors apply in some other aspects of mathematics, you can always put those questions and comments on the comment section below. And please subscribe to my channel to actually keep getting more mathematical videos and interesting videos about applications of maths. And please subscribe to my channel. Thank you very much.